Good morning, students. Thank you very much, students, for clicking on my video. I'm your Naginimam chemistry mentor. In today's section, I'm going to discuss about the Werner's theory, students. Okay, now how to solve the coordination compounds from Werner's theory. This is the topic from the coordination compounds 12th class. Clear? So in this section, I'm explaining five best tricks, students. So first trick number one is trick number one. Total five tricks I'm going to explain, students. Five tricks. First one is structure of the coordination compound. Structure structure of the coordination compound. Second one is formula of the coordination compound. Formula of the coordination compound. Next, third one is number of ions formed. Number of ions formed. Number of ions formed. And next, fourth one is the number of moles of AgCl formed. The number of moles of AgCl formed. Last one is conductivity. So these all five tricks, Nana, I'm going to calculate, students. Okay, now I will explain. So in Werner's theory, we know that Alfred Werner, he is the scientist. Okay, now he gave the structures of the coordination compound and he formulated the coordination compound, students. Okay, now so whenever first of all, Werner's theory. Now I'm discussing the Werner's theory, students. Werner's theory. So what he said, students, the central metal atom is having the two types of valencies. One is primary, secondary valencies, correct? So first of all, I am taking the metal. Metal is exhibiting the two types of valencies. One is primary valency. Second one is secondary valency. Clear? So primary valency indicates oxidation number, students. It indicates the oxidation number. Next, secondary valency indicates the coordination number, students. It indicates the coordination number. Clear? It indicates the coordination number. Right. Now, primary valency is ionizable, students. Primary valency is ionizable. Okay. Second point is it is secondary valency is non-ionizable. It is non-ionizable. And next, primary valency is it is non-directional. Clear? It is non-directional. And secondary valency is directional. Clear? Secondary valency, what, students? It is directional. Next, fourth one is it is primary valency represented by dotted line. Secondary valency is represented by solid line. Clear? Dotted line, solid line. Right. Now see, students. So Werner, what observed, see, students, here? Cobalt 3 chloride with ammonia, it is added to the silver nitrate solution. Okay, na? Silver nitrate, when it is added to the COCl3NH3. So to this compound, when silver nitrate is added, he observed different moles of AgCls are formed. Okay, now so based on that chemical reaction, students, he gave the formula of the coordination compounds. Clear? So first of all, here I'm taking the different chemical compounds, coordination compounds. See here, COCl3 6 moles of ammonia. I'm taking here COCl3 6 moles of ammonia. Next, COCl3 6 moles of ammonia. When we added AgNO3 solution, okay, it gives the 3 moles of AgCl, students. It gives 3 moles of AgCl and COCl3 5 moles of ammonia, COCl3 4 moles of ammonia, COCl3 3 moles of ammonia I'm taking. Now, when added silver nitrate solution to this compound, it is giving Nana 2 moles of AgCl. It produces, whenever silver nitrate is added to this compound, it produces 1 mole of AgCl, and when silver nitrate is added to this compound, it produces 0 moles of AgCl. Clear? It is not producing silver chloride. That means when silver nitrate is added to the cobalt 3 chloride ammonia solution, okay, now it is producing different moles of AgCl, students, different moles of AgCl. So from this chemical equation, students, he concluded the formulas. That means he finalized the formulas of the coordination compound, students. Okay, now one by one we'll discuss, students. So first I'm taking the first reaction, COCl3 6 ammonia. So I'm taking the first of all structure, students. COCl3 6 moles of ammonia. Clear? COCl3 6 moles of ammonia. This all here what I discussed, your primary valency, secondary valency, these points I will discuss in the structure, students. Okay, now see Nana, first I am taking this first one, COCl3 6 ammonia compound. Now COCl3 first one, COCl3 6 moles of ammonia I am taking. Okay, 6 moles of ammonia. Now how to write this structure? Now see, students, structure, coming to the structure, what is the central metal atom, students? Cobalt. Clear? Central metal atom is cobalt. Now I am taking the central metal atom cobalt. Around the central metal atom I am taking the 6 bonds, coordination number 6. Okay, coordination number 6, COCl3 6 ammonia. Here also I am taking the second compound, COCl3 5 moles of ammonia. Next, third compound, COCl3 4 moles of ammonia. Next, fourth compound, COCl3 3 moles of ammonia. Okay, now these 4 compound structures I am taking, Nana. See here, COCl3 6 ammonia. So here around this central metal atom, total 6 bonds, coordination number 6, students. I am taking coordination number 6. Okay, total 6 bonds will be there. That means coordination number is nothing but the number of ligands. Okay, now the ligands which are present around the central metal atom. Okay, now so how many ligands are present around the central metal atom, that indicates the coordination number. Okay, that means see here ammonia. So maximum, students, here coordination number, here ammonia, it is a neutral ligand, it is a neutral. So neutral molecules are comes under, students, secondary valency, that is the coordination number. Okay, now secondary valency indicates the coordination number. So here maximum, students, neutral molecules comes under secondary valency, students, neutral molecules. Clear? Neutral molecules. Here maximum primary valence is nothing but, here we can take negative ions. Clear? Negative ions. Okay, primary valency. Now see, students, here ammonia is a neutral molecule, so that's a total how many molecules are there? 6 ammonia. So these ammonias are acting as which one, students? These are secondary valencies, correct? These are secondary valencies. I told you neutral molecules are acting as a secondary valency, and negative ions, chloride, its charge is -1, that's why it is acting as a primary valency, students. It is acting as a primary valency. Clear this one? Primary valency. So here coordination number means, here around total 6 bonds are there, 6 ammonia molecules I am writing here, 1 2 3 4 5 6. Clear? 6 ammonia molecules are there. Okay, so to complete it is satisfied, coordination number 6, Nana. Coordination number 6. How many chlorines are there here? 3 chlorines are there. That 3 chlorines you have to, that is the primary valency. Okay, now so secondary valency is represented by dot. It is represented by solid line. Already I told you here it is a solid line. Secondary valencies are represented by solid line. So that's why these are all solid lines. Now primary valencies I am writing. So that means these 6 NH3 ligands are present inside the coordination zone or inside the coordination sphere or entity. Okay, now remaining 3 chlorines are there. These 3 chlorines are present outside the coordination zone. Okay, now so this is primary valency. It is represented by dotted line. So that's why I'm taking like this. This is dotted chlorine, one chlorine here, and one more chlorine here I'm taking, and next another chlorine here I'm taking. Understanding students? Here one, here one, here one. Total 3 chlorines I'm taking. Okay, now here only should take. There is no matter, students. You can take anywhere. Understanding? 3 chlorines here you can take, or here anywhere you can take. Okay, now so that is your wish. So here I'm taking here 3 chlorines. These 3 chlorines are present outside the coordination zone. Clear this one? Outside the coordination zone. Right, now here I am taking COCl3 5 ammonia. See here this structure, students. What is the central metal atom? Cobalt. Okay, now first write here 6 bonds around the cobalt. So here ammonia is the secondary valency. It is secondary valency. And next this is the primary valency. Sometimes, students, primary valencies are acting as a secondary valencies also. Are you clear? So that means primary valency negative ion, sometimes they're acting as secondary valency also, as they can act both, as both, that is primary as well as secondary. In this case, like that only they're acting. See here, total 5 moles of ammonia. So here 5 ammonias are there. Here 1, 2, 3, 4 and 5. So one more bond is there. Here it is empty. So total 5 ammonia so completed. So here this is empty place. So in this place the primary valency will come, that is chlorine. Are you understanding? It is a primary valency, and it is represented by dotted line. Clear this one? It is represented by dotted line. That means this chlorine is acting as a primary valency as well as secondary valency. Clear? Secondary valency. So total coordination number 6 is satisfied. Remaining how many chlorines are there? One chlorine is over. Remaining 2 chlorines. That 2 chlorines are present outside the coordination zone. So that's why I am taking the 2 chlorines outside the coordination zone. Here one and here one. Okay, clear this one? Okay, now so then 2 chlorines are outside the coordination zone. Clear, students? How to write? Right, now third compound seen in a third structure. Here central metal atom is cobalt. Total how many bonds? 6 bonds around the central metal atom. Total here neutral ligands 4 ammonias are there. So 4 ammonias are acting as a secondary valencies, NH3, 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 NH3. Remaining 3 chlorines are there. Okay, now here still 2 bonds are there. Here 1 chlorine, here 1 chlorine. These 2 primary valencies are acting as a secondary valency. So take here dotted line. That means it is acting as a primary valency as well as secondary valency. Are you understanding? So it is acting as a primary as well as secondary valency. So 2 chlorines over, remaining 1 chlorine. Still here coordination number 6 is satisfied. One more chlorine is there that you can take outside the coordination zone. So that means I am taking here like this, 1 chlorine, 1 more chlorine. Okay, this is the structure. And coming to the COCl3 3NH3. So in this one COCl3 NH 3 moles of NH3, I am taking the central metal atom cobalt. Okay, 3 ammonias are there. Here 1 ammonia, 2 and 3. Okay, now still 3 bonds are there. 3 chlorines are there. 3 chlorines are acting as a secondary valency as well as a primary valency. Clear this one? This like this. Okay, here there is no extra chlorines. Here only coordination number 6 is satisfied. Clear this, students? Coordination number 6 is satisfied. Okay, coordination number 6 satisfied. Now how to write, students? Here this is the structure completed. Structure completed, students. Now, to this compound, whenever silver nitrate solution is added, how many moles of AgCl it is giving? How many moles of AgCl giving? Okay, now. So, how to write, students? How many moles of AgCl it is giving? So, whenever added AgNO3 solution, silver nitrate solution, it is producing 3 moles of AgCl. 3 moles of AgCl it is producing, students. Okay, so how it is formed? How it is giving the 3 moles of AgCl, students. How can you write the formula of the compound? This one, how can you write? See here, CO, NH3, how many total? 1, 2, 3, 4, 5, 6. They are in the coordination zone inside the sphere, inside the square bracket. So I am writing the formula, this one. This formula I am writing, students. CO, NH3, how many are there, students? NH3, total how many are there? NH3s, total 6 are there. Okay, they, you should write that 6 ammonias inside the square bracket. 1, 2, 3, 4, 5, 6. These 3 are non-directional. Are you clear? 3 chlorines, dotted lines. These 3 are primary valencies. 3 chlorines are outside the coordination zone. So that's why I am taking here 3 chlorines, Cl3. Understanding? 3 chlorines are outside. Understood this one? This is the formula of the compound. This is the structure. This is the trick number 1. How to write the structure of the compounds, coordination compounds. Trick number 1 over. Now I am discussing the trick number 2. How to write the formula of the compound. Formula of the coordination compound. Clear this one? How to write? Understood this one? Formula of the compound. Now second compound, see students, how to write the formula. Total cobalt central atom. Now see students, NH3s, how many are there inside the coordination zone? 1, 2, 3, 4, 5 only there. So CO, NH3, 5, and one more bond is chlorine. It is also acting as a secondary valency. Remaining 2 chlorines are present outside the coordination zone. So that's why that 2 chlorines you have to take outside the square bracket. Understanding? So this is the second compound formula. Understanding, students? Now see here, third compound structure, how to write. Central metal atom is cobalt. NH3 is how many are there? 1, 2, 3, 4, right? 4 and NH3, 4 molecules take, and remaining coordination number 6 na, 2 chlorines also, they are inside the coordination zone, and one more chlorine is present outside. So that is acting as a primary valency. Now coming to last structure, students, CO, NH3, how many are there? 3 are there, and remaining 3 chlorines also present inside the coordination zone. 3 chlorines, any outside the coordination zone there? No, there is no primary valencies. All 3 chlorines are acting as a secondary valencies only. Okay, now as acting as primary as well as secondary valency. So here all are inside the coordination zone. There is no outside the coordination zone. So that's why these are the formula, students. Clear this one? This is the trick number 2, how to write the formula of the compound. Next one, trick number 3, how many ions are formed? Number of ions, how many ions are formed? Now I am taking this compound, students. Okay, when it is added to the water, first of all, when it is dissolved in water, it is giving how many ions? See here, now I am taking CO, NH3 6 times, Cl3. Okay, Cl3, when it is added to the water, dissolved in water, it is producing how many ions? See here, we know that inside the coordination zone, what are the ions, what are the molecules are there? They will not dissociate into ions. This coordination zone completely, it is one ion. It is non-ionizable. Already I told you. Okay, now it is non-ionizable, students. Coordination zone or coordination entity, it is non-ionizable. When it is added to the water, it is completely one ion. CONH3 6 times. Okay, this is one ion, and 3 chlorines are there. It is first of all dissociate into, this is 1, and this 3 chlorines like this dissociate, and here this 3 will come to here charge 3 plus, and chlorine is negative charge. This is cation, this is anion, this is positive charge, this one is negative charge. Clear this one? So first write, students, here this one is one ion and 3 chlorines are there, right first, and this 3 will go to here, and this here this is one square bracket part is there, so this one will come to the chlorine side. So -1, this is +3 charge. Total how many ions are formed, students? 3 chloride ions, so 1 this coordination zone. Total how many ions? 3 ions, this is 1 ion. Total 4 ions are formed. Clear this one? This is a trick number 3, number of ions formed. Trick number 3. Clear this one? Trick number 3. Understood? 4 ions are formed. Okay. Now these 4 ions, four ions are formed. Now this compound CONH36 plus 3, okay, and 3Cl minus ion. To this compound, these ions, when silver nitrate is added, how many moles of AgCl is formed? That is the fourth trick. Now see students, trick number 4. Trick number 4. Now here in this case, here CONH36 plus 3 3Cl minus CO, here what is formed here? Trick number 3, take that one here, plus 3 and 3Cl minus. When it is added to the silver nitrate solution, what is happening? Silver nitrate solution. Now see students, this is the coordination zone. It will not dissociate into ions. Total outside the coordination zone, 3Cl minus ions are there. Whenever silver nitrate is added to this solution, what is formed? 3 chlorines now. So that's why silver, it is 3 moles if you take here, then 3 moles of AgCl is produced. It is forming 3 AgCl. Clear this one? Because 3 Cl minus ions are there. So that's why when silver nitrate is added, total 3 silver chloride ions, 3 moles of silver chloride is formed. Clear this students? This is a trick number 4. Okay, trick number 4. Now see, tell me students, this one, how many ions giving? First compound I discussed you. Second compound, tell me students, second compound here, outside the coordination zone, when it is added to the water, students, how many ions it is giving? Outside the square bracket, how many chlorines are there? 2 chlorines are there. Okay, now so that's why it can total how many ions? So here 2 ions, so this square bracket part 1 ion. Are you understanding? Square bracket part 1 ion. Total 3 ions it is producing. Total how many ions it is giving? 3 ions. Understanding? 3 ions. Now see, outside the coordination zone, 2 chlorines are there. Okay, that's why whenever silver nitrate is added, how many moles of silver chloride is formed? 2 moles. Are you clear? How many moles of silver chloride is formed, students? 2 moles of silver chloride is formed. Clear this one? 2 moles of silver chloride is formed. Now tell me this one, this compound, outside the coordination zone, 1 ion and 1 chlorine is there. This is 1 square bracket part. Total how many ions? When it is added to the water, it dissociate into how many ions? 2 ions. Clear this one? When it is producing how many ions, students? 2 ions. Okay, and this compound, when it is added to the silver nitrate solution, outside the coordination zone, only 1 chlorine is there. So that's why it can form only 1 mole of AgCl. It can produces only 1 mole. 1 mole of AgCl. Clear students? Clear? Here 3 chlorines are there outside the coordination zone. So that's why it can produces how many when it is added to the silver nitrate solution, how many moles of AgCl formed? 3 moles of AgCl, because 3 chlorines are there, 3 AgCl. Here how many chlorines are there? 2 chlorines. That's why it can produce 2 moles of AgCl. It here only 1 mole of chlorine is, only 1 chlorine is there. So that's why when it is added to the silver nitrate, it produces only 1 mole of AgCl. Now here, is there any outside the coordination zone, any chlorines are there? No. So that's why when it is added to the silver nitrate solution, how many moles of AgCl is formed? 0. Clear this one? Here I told you already, 0 moles of AgCl. So it is not producing. How many ions are formed when it is added to the water? Only 1 ion. Are you understanding? So it is not dissociated into the ion. First of all, it is not dissociated into the ion. When it is added to the silver nitrate solution, students, 0 moles of AgCl is formed. 0 moles of AgCl. Clear? 0 moles of AgCl. It is not giving any agent. So this till here trick number 4 is completed. Now we are going to discuss the trick number 5. What is the trick number 5? Conductivity. I told you. What is the conductivity? In this conductivity, I am discussing the 2 cases, students. Conductivity, I am discussing the 2 cases. Now trick number 5. See, trick number 5, conductivity. In conductivity, students, here you have to remember the 2 cases. First case is number of ions more then conductivity also more students. Number of ions more, conductivity also more. See here, in these four compounds, which is having the more conductivity? Now tell me students, number of ions. So this one, how many ions giving? Total 4 ions, correct? Total how many ions it is producing? Total here 3, this is 1, total 4 ions. I told you already, 4 ions giving. It is how many ions? 3 ions it is producing. It is 2 ions. Clear this one? 2 ions. It is giving only 1 ion. Okay, it is giving only 1 ion. Yes. So here which is having the more conductivity students? More number of ions are increases, conductivity increases. So more the number of ions, more is the conductivity. So it is having the 4 ions, so that's its conductivity is more. So what we can write order students? What we can write order? So conductivity, which one is more? First one is more, greater than, second one greater than, third one, and greater than fourth one. Clear? This is the first case. Okay, this is the case 1. Next, second case students, in conductivity charge. If the charge of the coordination zone, okay na, coordination zone, charge of the square bracket part, okay, zone coordination zone is more, conductivity also more students. Coordination zone charge is more, okay na, then conductivity also more. See here, this is the square bracket part, first compound, here charge is +3. Second compound, how much students? Here 2 is there, +2. Here only 1 chlorine, +1. This is the coordination zone, square bracket part. It is having how much charge students? How much charge it is showing? It is showing +3. It is showing +2. 2 chlorines. This 2 will come to here charge. Here 1 chlorine, only +1. Here no, nothing, no charge. Now tell me students, which coordination zone is having the more charge? This one. Clear? So that's why conductivity which one is more? First one is more. So that's why conductivity is more to first compound. Clear this one? As it is, you can write first 1 is greater than, 2 is greater than, 3 is greater than 4. Clear? Clear students? So total how many tricks I discussed? 5 tricks I discussed in this Werner's theory. So he gave the formula of the compound, structure of the compound. So from this structure and formula of the compounds, we can write the number of how many ions are formed, and when it is dissolved in water, how many ions are formed, and when it is added to the silver nitrate solution, how many moles of AgCl is formed, and conductivity 2 cases. Okay, now which compound is having the more conductivity? So here 2 cases I told you, number of ions are more, conductivity is more, and charge of the coordination zone, which one is more? The coordination conductivity also more. Clear students? Clear students? Okay, I hope you like this video students. If you like this video, please like, share, comment, and subscribe my channel students. Thank you very much students.